Welcome to section 3.2, numeric data. In this lesson, we'll explore how Java represents and handles numbers, from simple integers to floating point values. Our learning objectives today are to understand different numeric types in Java, perform math using these types, and learn how parentheses affect order of operations. Let's start with a bit of history. Early computers used punch cards to represent data. Each hole represents a 1 and each blank represents a 0. Auto pianos read punch cards to trigger keys. Each column controlled one note, and the presence or absence of a punch determined whether a note is played. In modern computing, we still rely on binary. Just like the punched holes, we use ones and zeros. These bits form the foundation of all computing. Each bit can represent two states. With more bits, we get exponentially more combinations. For instance, 2 bits give us 4 combinations. 3 bits give us 8 combinations. 8 bits, what we call a byte, give us 256 different combinations. A byte in Java can store values from -128 to +127. Trying to store 128 in a byte will result in an error because it exceeds the byte's limit. Java has several integral types. A byte is 8 bits, short is 16, int is 32, and long is 64 bits. Larger types can store larger numbers. There are 4 integral or whole number primitive types in the Java programming language. You have already been using the int data type, so let's focus on the other 3. Integral types are used to store numbers that don't have decimal portions. They are shown here in order of size: byte, if you need to store people's ages. A variable of type byte would work because byte types can accept values in that range. Short, a short will hold 16 bits of data. Long, when you specify a literal value for a long type, put a capital L to the right of the value to explicitly state that it's a long type. Integer literals are assumed by the compiler to be of type int unless you specify otherwise by using an L indicating long type. You can express any of the integral types as binary, zeros and ones. For instance, a binary expression of the number 2 is shown as an allowed value of the byte integral type. The binary value is 0b10. Notice that this value starts with 0b, that is 0 followed by either a lowercase or uppercase letter b. The letter indicates to the compiler that a binary value follows. Most of the time, we will use int for whole numbers. Byte and short are rarely used unless memory optimization is critical. Let's explore how values can be assigned to variables. A variable holds its value until it's reassigned. We can assign calculated values or use shorthand operators like += or ++ to increment the variable. You can also assign one variable to another, but remember, changing one variable won't affect the other. They are independent. Java supports the usual math operations, addition and subtraction using plus and minus as shown here. We also have multiplication and division using asterisk and slash. Division discards the remainder if you are using integers. Java has shorthand operators like += and -= which allows you to update variables more concisely. Other shorthand operators include asterisk equals, slash equals, and modulo or percentage equals for multiplication, division, and finding remainders. The modulus operator, %, returns the remainder of a division. It's useful in many logic and loop conditions. Java allows increment and decrement using plus plus and minus minus. These operators are shortcuts to add or subtract the value of 1. A common requirement in programs is to add or subtract 1 from the value of a variable. You can do this by using the plus operator as follows. Age equals age plus 1 or age plus equals 1. Pre-increment plus plus x updates the variable before it is used. Post-increment x plus plus updates after it is used. Same for decrement with minus minus. You have used increment and decrement operators before, placing them after the variable that you want to affect. But did you know that these operators can come before pre-increment and pre-decrement or after post-increment or post-decrement a variable? When you put the plus plus or minus minus operator before a variable, the value is changed immediately. When you put the operator after the variable, it isn't changed until after the expression is evaluated. In the first code example in the slide, ID is initialized to 6. In the next line, you see new ID equals plus plus ID. Because the operator precedes ID, this increment is immediately evaluated, and the value assigned to new ID is 7. In the second code example, the plus plus operator follows ID. ID was incremented after the assignment occurred. Therefore, new ID is 6. These same behaviors apply to the decrement operator for its placement before or after the variable. Let's apply those operators. This example shows how pre and post increments affect variable values. In exercise 1, you will simulate egg collection using integer variables and changing values based on the story events. The goal is to output the correct number of eggs collected in 2 different scenarios. Try it out and compare your results. But watch out, integer division may give surprising results. For example, 9 divided by 2 will return 4, not 5. That's because Java truncates the result when both operands are integers. No rounding happens, Java just drops the decimal. There are 2 types for floating point numbers, float and double. Again, we'll focus on the new data type here, the float. Floating point types are used to store numbers with values to the right of the decimal point, such as 12.24 or 3.14159. Float is used to store smaller floating point numbers. A float variable can hold 32 bits. Floating point values are assumed to be of type double unless you explicitly state that it is a float type, not a double type. You do that by putting a capital F to the right of the value. Note, use the double type when a greater range or higher accuracy is needed. Even using double, if the expression only includes ints, the result is still truncated before converting. You need to include a double in the expression. Adding a decimal like 2.0 turns the whole expression into floating point math. Now Java will preserve the decimal point. To make a variable unchangeable, use the final keyword. This is useful for constants like pi or max speed. Final variable names should be all uppercase with underscores. This helps distinguish them from other variables. In exercise 2, you'll practice calculating averages and profits using floating point math and proper precision. The output should show accurate decimal values for daily average, monthly totals, and calculated profit. Parentheses can completely change the result of a math expression. Use them to control the order in which operations are performed. In exercise 2, make sure you use parentheses appropriately. Java follows a standard order of operations, or precedence, when evaluating math expressions. In a complex mathematical statement with multiple operators on the same line, how does the computer pick which operator it should use first? To make mathematical operations consistent, the Java programming language follows the standard mathematical rules for operator precedence. Operators within parentheses are evaluated first, then multiplication and division, followed by addition and subtraction, all left to right. Use parentheses to make your intentions clear, especially in complex formulas. It helps avoid bugs and makes your code easier to read. To summarize, you've learned how to use numerical data in Java, distinguish between different data types, perform calculations, and write expressions using proper structure and order.